Hello, hi everyone. So, welcome to the class. This is our Shiva sir from Student Brand. So, today we are going to discuss about magnetic effects of electric current. Magnetic effects of electric current. Okay, let's get into the topic. Magnetic effects of electric current. Magnetic magnetic effects of magnetic effects of electric current. Electric current. Magnetic effects of electric current. So that is nothing but, so now you can see magnetic effects of electric current. When the current is passing through the conductor, it acts, it exhibits, it produces, it behaves as a magnet. So when the current is passing through the conductor, the current is passing through the conductor, it produces, it acts, it behaves as a magnet. Okay, so that is nothing but, so magnetic effects of electric current. By passing the electricity through the conductor act as a magnet. Okay, so that is about magnetic effects of electric current, right? Now we will first of all we have to discuss about magnet. What exactly the magnet, what are the properties of magnet, how it will behave. Okay, so magnetite or lodestone, is a natural magnet which occurs from earth crust. Okay, so which occurs from the earth crust. And coming to the second point, okay, so there are two types of magnets are there. Those are artificial magnets and natural magnets. Coming to the natural magnets which occurs from the earth crust, already we know that. Coming to the artificial magnet, man-made magnets, those are called artificial magnets. So according to our requirement, according to our uses, so we are preparing the magnet. That's why it is called man-made magnets or artificial magnets. I hope it is very clear. Man-made magnets are artificial magnets, right? So coming to the next one. So magnet has two poles. Those are north pole and south pole. If you drop this magnet, suppose if you consider this a magnet, if you drop the magnet into the sand, okay, so what happens? It will attract the magnetic material at the poles. So at the poles, at the ends of the magnet, it will attract the magnetic materials. Those are called poles. So poles has equal strength. Okay, poles has equal strength. So they both have equal strength. So north pole and south pole both have equal strength. Understood? Equal strength. And so magnetic materials will attract at the ends than in the middle. It will attract at the ends. Okay, so there is nothing but at the poles than in the middle. Understood? So here now I am talking about bar magnet. So we'll discuss about bar magnet. Bar magnet has two poles. Okay, those are north pole and south pole. And coming to the magnetic field. Okay, so the region around the magnet. So if you are taking this a magnet, so north pole and south pole. So this is the north pole and this is south pole. Okay, so north pole and south pole. The region around the magnet in which magnetic force exert. The region around the magnet in which magnetic force exert is called magnetic field. The region around the magnet in which magnetic force exert or magnetic field experience, or magnet will experience the force on magnetic materials, that is called magnetic field. Only certain region. So if I am taking this a magnet, okay, so suppose if you consider this a magnet until certain region only, the magnet will attract the magnetic materials. Until certain region only, the magnet will attract the magnetic material. Beyond the point, more than certain point, it won't attract the magnetic material. Until certain region only, the magnet will attract the magnetic materials. Okay, so that is called magnetic field. The region or the space around the magnet in which magnetic force exert is called magnetic field. And coming to the magnetic field will be in the form of field lines. So we'll discuss about magnetic field. Magnetic field. So magnetic field, first one. Coming to the magnetic field lines. Magnetic field lines. Magnetic field lines. Understood? Magnetic field lines. Okay. So coming to the magnet, the region or the space around the magnet in which magnetic force exert is called magnetic field. So here around the magnetic field will be like this. Around the magnetic field will be like this. Okay. So here you can observe like this. This is a magnetic field and this is a magnetic field. And coming to the middle, so you can take the lines like this, and here also you can take the lines. Understood? So north to south, we can take this north to south, and here I am considering like this. So it is moving away from it, and towards the pole it reaching to the point. Understood? So from north pole it is moving. So towards the south pole it reaching. So from north pole the magnetic field is leaving. Towards the south pole it is reaching. The region or space around the magnet in which magnetic force exert is called magnetic field. Okay. Magnetic field will be in the form of field lines. Those field lines emerge out from north, reaches to south. So outside of the bar magnetic field is north to south. Inside of the bar magnetic field is north to, so inside of the bar magnet is south to north. Outside of the bar magnet the magnetic field is north to south. Inside of the bar magnet the magnetic field is south to north. Okay, so the magnetic field is south to north. Outside of the bar magnet is north to south. Inside of bar magnet the magnetic field is south to north. Understood or not? South to north. I hope it is very clear. Understood or not? Okay, so I hope it is very clear. Understood? So outside of the bar magnet, the magnetic field is north to south. Inside of the bar magnetic field is south to north. I hope it is very clear. Understood? That is a magnetic field. So coming to magnetic field lines. So these field lines emerge out from north and merge at south. Okay? Emerge at north. So merge at south. Okay, outside of the bar magnetic field is north to south. Inside of the bar magnet is, so magnetic field is south to north. And these field lines never intersect. Okay, these field lines never intersect. If it is intersects, so what happens? Okay, if it is intersects, so what happens? So at the point of intersection, so these field lines never intersect. So normally magnetic field, you can observe. So if you want to identify the magnetic field around so magnetic field around the bar magnet, so if you place compass, automatically deflection will be shown. By that we can understand magnetic field is there. So compass, so you have to place the compass near to the magnet to identify the magnetic field. Understood or not? So deflection will be shown in the compass. Compass is nothing but a small magnetic needle is present inside of it. Okay. So that always shows north and south direction. You can see this is north, south and east west, north south east west, it always shows north and south direction, it always shows north and south direction. Understood or not? So what happens? So here if field lines intersect, so our point is, if field lines intersect, what happens? If field lines intersect, so if two magnetic field lines intersect, what happens? So what happens? So at one point, compass should show two directions where it is not possible. Compass should show two directions where it is not possible. Only at a time, only one direction only compass will show, that is north and south. Okay, so if it is there, and one more point also I'll tell. After that, you will get the clarity on it. So normally, if you want to identify the magnetic field at a particular point, so normally we know that magnetic field will be outside of the bar magnet is north to south, inside of the bar magnet is south to north. We know that. But one point is, if you want to identify the magnetic field around the bar magnet or around the so anything, so if you want to identify the magnetic field, so we know that magnetic field will be in the form of field lines. Magnetic field will be in the form of field lines. If you draw the tangent to the magnetic field line, so if you draw the tangent here, so at this point, if you are you are going to find out the magnetic field at this point. So simply you have to draw the tangent. Simply you have to draw the tangent. If you draw the tangent, that's enough along the direction at that particular point. So overall we know north to south. But at this particular point, what is the direction of the magnetic field? At this particular point, what is the direction of the magnetic field? We know that if the object is moving in a circular path, so the velocities keep on changing. If it is uniform motion, okay. So if it is uniform motion, so speed will be constant, but velocity changing, right? Keep on. If the object is moving in a circular motion, velocity changing, right? Velocity changing at each and every point. Here also same thing. You can observe at that particular point. If you want to identify the magnetic field, at particular point, if you want to identify the magnetic field, you have to draw the tangent to the magnetic field lines. Along that particular direction, the magnetic field will be present at this point. And if you want to identify the magnetic field, you have to draw the tangent. So wherever you want to identify the magnetic field, so just simply if you draw the tangent to the magnetic field line, then along that particular direction, you can get the magnetic field. Okay, at that particular point. Okay, overall, outside of the bar magnet, magnetic field is north to south. Inside of bar magnet is south to north. We know that. So here, so sir, why you are saying all these points? So what is the reason? So as I mentioned, if two magnetic field lines intersect, what happens? So compass should show at a time two directions where it is not possible. So here if these two field lines are intersecting, so along this direction magnetic field is, So compass should show two directions where it is not possible. Compass will show at a time only one direction, that is north to south only. Compass will show only one direction, that is north and south. Okay, north south. So like this, somewhat tilted, it will be north to south. Understood? So it cannot show two directions, right? So like a west, north, east. So it is not possible. Right? So that's why these field lines never intersect. So these are the points related to magnetic field lines. First one, magnetic field. Magnetic field is nothing but the region around the magnet in which magnetic force exert. around the magnet, the magnetic force exists, that is called magnetic field. That is called magnetic field. That's the point number 1. And coming to the point number 2, around the magnet, the magnetic field will be in the form of field lines. So you can observe, these are the field lines. Outside of the bar magnet is north to south, inside of the bar magnet is south to north. And these field lines are closed loops. These field lines are closed loops, and these field lines never intersect. These field lines are closed loops. At the same time, these field lines never intersect. If it is intersect, so compass should show at a time 2 directions where it is not possible. So this is about magnetic field and magnetic field lines. Understood? So next one. So I'll discuss about loop. So you can take 7 lines, 9 lines, magnetic field lines to draw the clear, neat, proper diagram. Understood? And coming to the next one, loop you have to take. So I'm taking the loop. So here you can observe, this is the loop. So positive terminal, negative terminal, current is going like this. Okay, so around the wire, so the like this magnetic field will be there. Around the wire magnetic field will be, and here also magnetic field will be like this, and here also magnetic field will be like this, and here you can observe. So you can, and here at the middle it will be straight lines, and this one is the north pole because magnetic field is leaving here like this, reaching, leaving, So sir, how can you say like that? Simply, how can you say like that? By using what rule we can identify? By using right hand thumb rule. If the current is passing like this, okay, so if the current is passing like this, so along the current direction, so just suppose if the current is passing like this, so along the current carrying direction you have to place the thumb. Okay, by using right hand thumb rule, we can identify the magnetic field around the current carrying conductor. So current is passing along this direction. So you have to place the thumb towards the direction. 4 leaf fingers, folding fingers, curly fingers, wrapping fingers. Along this direction, magnetic field will be there. So this is the current direction. If you place the thumb along the current direction, folding fingers, curly fingers, okay, wrapping fingers shows the magnetic field. Okay, so magnetic field direction. So here you can observe current is passing. So if the current is passing upward direction, so magnetic field will be like this. So leaving, reaching. So leaving like this. So here you can observe. So here also if the current is passing like this, it will be like, understood? So it will be like, so that is a north and that one is south. Okay, so by that we can identify. This is the loop. And one more very, very important point. So current carrying conductor. So current carrying long straight copper conductor. So that is very important. So few points are related to that. I will explain about it. After that we'll go to the solenoid. Okay, so current carrying long straight conductor, long thick straight conductor. So I'm taking this one. So current is passing like this. So this is ammeter, and so variable resistance. Here you can see battery. This is the battery, like this I am taking. Okay, so switch. This is the switch, and the current is passing like this. Understood? So current is positive terminal, negative terminal. Current is passing like this. So it acts as I mentioned, a current carrying conductor produce or acts or behaves as a magnet. So if the current is passing through the long straight copper conductor. Current is passing, right? So it acts as a magnet. It acts as a magnet. So around it, magnetic field will be produced. Magnetic field will be produced. So you can observe. So you can observe like this. You can observe like this. Okay. So if the current is passing through the conductor, so magnetic field will be produced. Magnetic field will be in the form of concentric circles, closed loops. Magnetic field will be in the form of closed loops, closed like this, closed loops. So closed loops like this. How the magnetic field direction? So you know that current direction. We know that this is the current direction. So that is north, south, east, and west. Okay, north, south, east, west. Right. So current is passing from north to south. So current direction I am taking along this direction. I is moving from north to south. Sir, how can you identify the magnetic field direction? So current is passing from north to south. We know that. So according to the battery, so current will pass from positive terminal, negative terminal. We know the current direction. Sir, how can you identify the magnetic field? Magnetic field direction around the current carrying conductor. Magnetic field direction around the current carrying conductor by using right hand thumb rule. So current is moving upward direction. Curly fingers, folding fingers, wrapping fingers shows the magnetic field direction. So earlier I mentioned in the loop question. So if the current is passing downward direction, curly fingers, folding fingers, wrapping fingers, curly fingers or folding fingers or wrapping fingers shows the magnetic field. So even if you are taking upward direction, so current is moving upward direction. So if you wrap the fingers around the current carrying conductor, okay. So along this one, along the folding fingers, the magnetic field will be there. Magnetic field direction. Here you have to identify the magnetic field direction. Magnetic field direction you have to identify. So current is moving upward direction. So folding fingers curling along the curly fingers direction, the magnetic field will be there. Magnetic field will be there. So here along this direction the magnetic field will be there. Along this direction, so the magnetic field will be there like this. So if you change the current direction, if you change the current direction, automatically magnetic field direction also changes. So your current direction you took like this. If I change the current direction like this, so magnetic field direction also changes. Okay, by changing the current direction, magnetic field direction also changes. Magnetic field direction also changes. And one more thing, so here you can observe, if you place the compass here, so as I mentioned, compass is a small magnetic needle present inside of it. If the current is passing from north to south, so compass deflection will be shown towards east. If the current is passing from north to south, the deflection in the compass will shown towards east. If the current is passing from south to north, deflection will be shown towards west. I hope it is very clear. So if the current is passing through the conductor, deflection will be shown towards east. If the current is passing from south to north, deflection will be shown towards west. Sir, how can you understand? Okay, so now you can observe. So if the current is passing like this, so I hope it is very clear. So now you have to understand one thing. That is if you change the current direction, magnetic field direction also changes. If you change the current direction, magnetic field direction also changes. And one more point, near to the conductor, magnetic field will be more. So if you move away from the conductor, magnetic field will be less. And one more point, so magnetic field is directly proportional to strength of current. Okay, if more current, more magnetic field will be. Less current, less magnetic field will be there. So magnetic field is directly depends on strength of current. current. And one more point, so if more crowdings will be there, so magnetic field lines are there at one place, more magnetic field lines are there, it represent more magnetic field, it represent more magnetic field, more magnetic field. I hope it is very clear, understood? So these are very very important points, very very important points. So keep in mind, keep in mind. So this question will come for 3 marks. Okay, this question will come for 3 marks. And coming to MCQ's point of view, so there are many MCQ's points are there. So point number 1, if you change the current direction, magnetic field direction also changes. And if the current is moving from north to south, deflection will be shown towards east in the compass. If the current is moving from south to north, deflection will be towards west. Okay, and one more point is, near to the conductor more magnetic field will be there, away from the current carrying conductor magnetic field is less. Okay, this is a current carrying conductor, right? Near to the current carrying conductor more magnetic field will be there, away from the current carrying conductor less magnetic field will be there, means if you are moving away from the current carrying conductor. And one more thing, around the current carrying conductor, the magnetic field will be in the form of concentric circles. Around the current carrying conductor, the magnetic field will be in the form of concentric circles. If more crowdings will be there, so more magnetic field lines are there, so it represents more current, so more magnetic field, more magnetic field lines are there means more magnetic field, then anyway automatically current passing through the conductor also more only, so according to the magnetic field, understood? So this is about current carrying through straight conductor. Okay, so produce exhibit magnetic field. So by using right hand thumb rule, we can identify the magnetic field direction. By using right hand thumb rule, we can identify the magnetic field direction. I hope it is very clear. So that is about current carrying through straight conductor. Now I will explain about solenoid. Okay, so check here. So I am taking this as solenoid. This is the solenoid. Solenoid, so near to the conductor. This is the battery. So here you can take switch, current is passing. Okay, like this current is passing, right? So here the magnetic field lines, okay, it's very very important. So it is very very important, you can observe. So how many lines you have to take? 7 lines you have to take. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can take 7 or 9. So that is your choice. Sir, why 7 or 9? So you can go for 5 also fine. That is your wish. So my number is 9 I am taking. So it is good. Why? So 3 lines you can take above, 3 lines you can take below, and 3 lines middle. So you can connect 3 lines above like this. So around like this you can connect 3 lines, 1 and 2 and next one 3. So these are 3 lines, and next one you can connect here also 3, 1 and 2 and 3. So these are 3 lines, and in middle you can take 3 lines like this, and middle, and here also you can take 3 lines. You can take 3 lines. I hope it is very clear. So we know that magnetic field, okay, magnetic field. So if the current is passing towards this side, then this is south. If the current is leaving to this side, so that is north. So it's very 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 simple logic. You can check the textbook also. If the current is moving to that point, that you can mention as south. If the current is leaving from the point, that you can mention as a north. So it is from the textbook only. So you can remember easily. So you can take this one. This one I am taking, that is south. Okay, so if the current is moving to the side, at the same time magnetic field also reaches to the point. If the current is leaving to the point, so you can take the magnetic field also leaves. Actually, there is a rule. There is a rule that is clockwise rule. By using clockwise rule, we can identify. So anti-clockwise direction north pole. If the current is moving anti-clockwise direction, that is north pole. If the current is moving clockwise direction, that is south pole. Okay, so that face is north, that face is south. So we can identify by using clockwise rule. But for understanding, it is textbook diagram only. You can check the textbook diagram. Okay, so current is reaching to the point, that is south. Current is leaving the point, that is north. So simple way, easy way. So you no need to worry about it. So you'll not get confusion also. So never you'll get confusion once you remember these logics. Okay, so I will tell many logics in the class. Once you focus on the logics, so you never forget about diagrams. So proper diagram, clear diagram, neat diagrams, you can draw it at one time. At once you can draw proper diagram. So normally diagrams it will take more time to draw on the paper in the exam hall. What happens? So you draw one diagram, so it goes wrong. Again you are erasing. Again one more line. Again you are. It will take so much time. That too diagram based question, definitely they will give maximum marks. So this question will come for, if it is comes for 3 marks, so maximum 1.5 marks. 1.5 marks completed they will give for diagram, 1.5 marks. So they will carry for matter. So content what you write. So if it is completely, it is only for diagram, completely 3 marks you have to, okay na? So draw the diagram. For 3 marks you have to draw the diagram. But a current carrying conductor placed in the external magnetic field experience the force, that comes for 5 marks also. So that their diagram at the same time theory also very important. Okay, so here you can see a straight copper wire wrap in the form of cylindrical shape. A straight copper wire wrap in the form of cylindrical shape, that is connected to the battery. Current is passing, so magnetic field will be produced. And here you can observe this magnet. So here is north and this is south. So the magnetic field around the bar magnet, the magnetic field around the bar magnet, so you can observe. So solid act as a bar magnet. Solid act as a bar magnet. Magnetic will be produced same. So here also magnetic will produce same only. Okay, but here, so one point is we can increase the magnetic field. How can you increase the magnetic field? By increasing the strength of current. By increasing strength of current. Okay, so if you increase the current, automatically magnetic field also increases. And one more thing, if you increase the number of turns, so if you increase the number of turns also, magnetic field increases. Magnetic field increases. Understood or not? And we can change the poles, north pole and south pole are there, right? We can change by changing the battery polarities. So positive terminal, negative terminal, if you change those polarities, automatically magnetic. So solenoid poles also can change. Those are north pole and south pole. But here magnetic field is fixed, poles are fixed. We can't do anything. Understood or not? So this is about solenoid. I hope it is very clear. So next one. So we'll discuss about current carrying conductor placed in the external magnetic field experience the force. Understood or not? A current carrying conductor. So I'm taking this the current carrying conductor placed in the external magnetic field experience the force. So this I'm taking here. This is the stand like here. So and here I'm taking this the aluminum rod. So here you can observe. So this is north and south. AB current is passing. And here also current is passing. So positive terminal, negative terminal, positive. So switch. Understood or not? Current is passing like this. So here current is passing along this direction, current I. So current is passing through the conductor. A current carrying conductor placed in the external magnetic field. Okay. A current carrying conductor. A current carrying conductor placed in the external magnetic field experience the force. Experience the force. Understood? In which direction? In which direction? In which direction the conductor will move? By using Fleming's left hand rule. By using Fleming's left hand rule, we can understand in which direction the conductor will move. So by using Fleming's left hand rule. So index finger shows the magnetic field direction. So index finger shows the magnetic field direction, and so middle finger shows the current direction. Thumb finger shows the thumb finger shows the thumb finger shows the thumb finger shows the current carrier. So force acting on the conductor. Force acting on the conductor. Okay. So yes, I will answer all your questions. Okay. So definitely I will conduct a class like a session regarding interaction session. So definitely we'll discuss all those points. So related to subject point of view, if you have any doubts, you can ask. Okay. So we'll discuss all those points. Remaining definitely interaction session will be there. In that we will discuss all those points. Okay. So coming to the next one. So north pole, this is the magnetic field, north pole and south pole. So along this direction and current direction. So thumb shows the along the thumb shows the, so this direction. So in which direction thumb is showing? Along the direction. Along the direction, force will act on the conductor. Force will act on the conductor. Understood? So this is about force active current carrying conductor placed in the external magnetic field experience the force. By using Fleming's left hand rule, we can identify the force acting on the conductor. Force acting on the conductor. Okay, so that's enough. I hope it is very clear. And short circuit is nothing but the direct contact of live and neutral wire. Sometimes insulation. Actually, I have to choose Polytechnic after 10th class. So I got good rank also. But unfortunately, I went to intermediate and got into college, BTech college. So diploma is very nice course. Definitely you can continue. Okay. So directly after completion of the diploma, directly you'll go to the BTech second year. BTech second year. So that is very good. So you can join, no problem, by skipping intermediate. So directly you can go to the BTech. So extraordinary choice, you can go with that. So it depends. If you want to complete the course, and at the same time, based on diploma also, you'll get so many jobs. You can do technical jobs also. So technical job side, you can course side you can go. So right from channel. So right from starting off, so you can check the channel once you can understand the channel. Yeah, thank you so much. Definitely I'll do it. So I'll take rest. So right from my teaching. So whenever I started the channel, right from starting onwards, so I'm doing with a different different okay. So we can say teaching aid. Generally it is called teaching aid. So we can use different things to teach. Okay. So it is my way of teaching aid. So for everyone, their own individual things will be there for teaching. So it is a part of teaching it. So it is like that. Understood? And coming to the next one, where we are. So short circuit, the direct contact of live wire and neutral wire. So then heavy amount of current will be drawn from the mains. So and the next one, overloading. So high voltage appliances are too many appliances connect to the socket at a time, then heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains, then it may lead to the short circuit. Okay. So it depends. It depends on people choice and interest and concentration and focus. Okay. So thank you so much. Thank you so much for joining and attending and listening my class. This is your Siva sir. Please do like, share, and subscribe to Student the Brand. If you like the content, if you like the channel, if you like my explanation, so please spread one word regarding the channel. Okay, so extraordinary content will be there. Content will be okay, good. So in that, no compromise at all. So you can once check the channel, listen the channel, listen the lecture. Okay, once attend the class, listen the class, check with the textbook. No doubt at all, you can check with the textbook. CBSE science textbook, you can check with the textbook. Then you can get to know. Then if you like the channel, if you like the explanation, if you like the content, if content is good, explanation is good, then you can do like, share, and subscribe to Student the Brand and inform to your friends, ask your friends to join to the class and share to everyone as much as possible, as soon as possible. Okay, so thank you so much. So this is your Siva sir from Student the Brand. So we'll see you in the next class. Okay, so I'll see. As I said, so interaction session will be there. There I will discuss all the points. Thank you so much. We'll see you in the next class. Thank you.